Okay, let's go through the paper year 8. So, starting with question 1. It says, what is this number written to 3 significant figures? Remember, the first significant figure starts from the first non-zero number. So, all of these are zeros. The first one is 8, so that's 1, 2, 3. And it wants you to stop there. You have to decide, is it going to stay 0.00894 or round up to 0.00895? The next number tells you to round up because it is 5 or more. So this is our answer. So it's 0.00895. Write the number 65,731 correct to the nearest thousand. So this is the thousands column. So we're stopping it here. And we have to decide whether to keep it as 65,000 or round up to 66,000. Again, the next number along is 5 or more. So we're going to round up to 66,000. On the grid below, rotate shape X 90 degrees clockwise about 0, 0, which is here. So obviously I can't show you this on the iPad. Remember, you put your tracing paper over it, trace the shape, hold your pen or pencil on 0, 0, and do a 90-degree turn clockwise. So that's this way. 90 degrees, which is a quarter turn. Then you should end up with your shape being here. Okay, so that's where your shape should be. Okay. Right, write this number in standard form. It is not in standard form because this part is not between 1 and 10. So what we want, in order for it to be between 1 and 10, we want the decimal point to be here to make it 4.538. Now we've moved it 2 times. So we're going to add an extra 2 onto the indices here, so it becomes 10 to the power of 6. So 4.538 times 10 to the power of 6. Okay, here we have to decide which book is selling the textbook for the lower price. So here in Beachfield Books, we have a 16% increase. Now remember, to do an increase, we do 100%. Plus the 16%, and that means in total we have 116%. We turn it into a decimal by dividing by 100, which gives you 1.16. So to do a 16% increase, we're going to multiply by 1.16. Okay, so Beachfield, we're going to do $17.50 and times it by 1.16. And we can do that on our calculator, and that gives us $20.30. Now let's do Clifton. Now Clifton, it's a 20% reduction. So the same thing, we start off with 100%, but because it's a reduction, we are subtracting this time. So we're taking off 20% and we end up with 80%. Turn that into a decimal by dividing by 100, and that gives us 0.8. So to do a 20% reduction, we're timesing by 0.8. So we have $25.35 times by 0.8, which gives us $20 and 28 cents. And so you've shown all your work in, that's 2 marks. And for the last mark, you need to put your answer. So you put Clifton is selling the textbook for the lower price. So you must remember to put your conclusion. Okay. All right, write down the answers to these calculations. So we're multiplying by 10 to the power of 3. Remember, 10 to the power of 3 means we're timesing by 10, then by 10 again, then by 10 again. In total, we're timesing by 1,000. So we want to put on 3 zeros. So our answer is 3,205,000. Then B, divide by 10 to the power of 5. So our decimal point started off here. I mean, obviously, remember I told you that we're actually, mathematically, we're moving the numbers, but it's easier on the paper to imagine we're moving the decimal point, okay? So we're moving it 1, 2, 3, 4, 5 spaces. So it becomes 0.03205. C, we're timesing by 10 to the power of 8. So that's timesing by 10 8 times. And so we're going to move to this point this way 8 times. So it's going to be 1, 2, 3, and then 5 more times. And we'll put zeros in place for those 5 more times. So our answer here is 4, 8, 6, 7, and 1, 2, 3, 4, 5 zeros. So it is 48,670,000. No, it's not. 486,700,000. Okay, next one, we're dividing again by 10 squared. So we're moving the decimal point this way twice. 1, 2. So our answer is 0.04867. Okay. Another rounding to significant figures. This is the first significant figure. Then 2 is a second significant figure. So we cut it off here. So then again, we have to decide, are we going to leave it as 8.2 or are we going to round it up to 8.3? The next number is 5 or more. So we're going to round it up to 8.3. Number 8, so 8A, which one of these is the largest? Actually, this one's fairly straightforward. Looking at the biggest power, is 5.67 times 10 to the power of 5 is biggest. If we had powers that were the same, then we would have to look at the whole number. But because all the powers are different, we just look for the biggest power. Okay, work out 1.2 times 10 to the power 7 plus 2.3 times 10 to the power 6. There are 2 ways you could do this. You could turn it back into an ordinary number, which would give you 1, 2, and 1, 2, 3, 4, 5, 6 zeros. And then 2.3 times 10 to the power 6 is 2, 3, and 1, 2, 3, 4, 5 zeros. Add them up, which gives you this number here, which is 14,300,000. And then turn it back into standard form, because remember it says give your answers in standard form. You got 1 mark if you just left it like this. Okay, so we need it back into standard form. So to put it back into standard form, we're going to make it 1.43. And that means moving the decimal point 1, 2, 3, 4, 5, 6, 7. So it'd be times 10 to the power 7. The other way you could have done it, which I showed you, is 1.2 times 10 to the power 7 plus 2.3 times 10 to the power 6. You could turn this into 10 to the power 7. So 1.2 times 10 to the power 7 plus, if I turn it into times 10 to the power 7, I'm going to move the decimal point here to make it 0.23 times 10 to the power 7. And then I just add these two together. So I do 1.2 plus 0.23, which is 1.43. And so it's 1.43, and then this remains the same times 10 to the power 7. So there are two ways we could have done it. Okay, number 9, this is a percentage change question. So all we need to do is find the difference. So we do 39,000 because it's the bigger one. Take away 35,880. Divide it by the original, which is this, because it says it is reduced from 39,000. So that's the original, and then times it by 100. And you do that all on your calculator to get 8%. Okay, so that gives you 8%. Question 10, we're doing a percentage increase. So again, like I did before, 100% plus the 14% gives us 114% in total. Divide by 100 gives you the answer as a decimal, which is 1.14. So to do a 14% increase, we're going to multiply by 1.14. So $72 times 1.14. Again, grab your calculator and do it on there, and you get $82.08. B is another percentage change question. So again, we're going to find the difference. So we do 61.88, which is the bigger one out of the two. Take away 52, divided by the original. The original cost is $52. It says a bus ticket costs $52, then it's increased. So 52 is the original, and then times it by 100. Again, you can do that on your calculator to get 19% increase. So it's 19%. Okay, so reflect triangle J in the x-axis. The x-axis is here. So remember, it's just a flip from here to here. So we're just flipping it in the x-axis. And so make sure it's the same distance apart from the x-axis. So you would expect it to be 1 as well. Okay, so I mean, you can do this with with tracing paper as well, and just flip it in a line, but hopefully you can all do this without. And so here, again in its place, we're just in the same places, we're just putting it here. And this is now K. Okay. All right. Next, translate J by 4 squares to the right and 6 squares down. Now, Mrs. Wall did allow the mark if you didn't realise that you need to count the big squares, that each of these represents 1, and you ended up counting the little squares. For example, if you ended up doing 1, 2, 3, 4, and then going down 6 squares. So you were allowed that. We gave you a mark because it wasn't entirely clear on this, that you had to be careful with the squares. But the actual answer is, this is 1, 2, 3, 4 squares to the right, and then 1, 2, 3, 4, 5, 6 squares down. So that's where it should be now. Next corner, 1, 2, 3, 4 squares to the right, and then 1, 2, 3, 4, 5, 6 squares down. So that's where our 2 new corners are. And then I can quickly do this third corner. 1, so it starts from here. 1, 2, 3. So 1, 2, 3, 4 squares to the right, and then 1, 2, 3, 4, 5, 6 squares down. So that's where your new corner is, and that is L. Okay, find 3 to the power of 6. So you can just again do that to your calculator. I showed you how to do your indices. For most of you, it was pressing 3, then this button, and then 6, and then the equals button. For others of you, it's slightly different. I think some of you had this button here to press. Either way, you should have got 729. If you were super desperate, you could have just done 3 times 3 times 3 times 3 times 3 times 3. But that's the quick way. Now, to find the cube root of 6,859, remember it was the cube root, not the square root. So you were looking for this button here on your calculator. And if you put that in and you found the cube root of 6,859, it will give you the answer 19. Okay, another round into significant figures. So you want 4 significant figures. So you want 1, 2, 3, 4. So we're going to stop it there. And the rest we're going to fill with zeros. But first of all, we need to decide, are we going to keep the first 4 as 3, 4, 5, 7? Or 3, 4, 5, 8? Well, the next number is 5 or more, so we're going to round up. And then fill in the rest with zeros. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 with zeros. Okay, question 15. We need to find the distance between the distance in kilometres from Earth to Proxima Centauri. So it says that it's 4.22 light years away. And 1 light year is 9.46. So one of them is 9.46 times 10 to the power 12. But we want 4.22 of them. So we're going to multiply it by 4.22. And you can do that on your calculator, to be honest. If your calculator won't allow it, then simply multiply these two together, which gives you, I think, 39.9212 times 10 to the power 12, because you can't forget the 10 to the power 12. Then to make it standard form again, we're going to move the decimal point this way. So we need to add another one on there. So our answer is 3.99212 times 10 to the power 13. Okay, next question says, show that Buzz is correct, that it would take 114 years to get there. Okay, so first of all, hopefully you all know your formulae triangles. So speed equals distance divided by time. In this case, we want to find the time. So if we cover that up, it shows us that time equals distance. So distance is at the top, divided by speed. Okay. We know the distance. It says here that the distance is this here. So we're going to do 3.99212 times 10 to the power 13. And we're going to divide by the speed, which is 40,000 kilometers per hour. So 40,000 here. So we need to divide it by 40,000. So we do that, and that gives it to us in the time in hours. Okay, so if we do that on our calculator, just turning mine on quickly, times, so I'm going to divide, may not allow me to do the times 10 to the power 13, I'll see if it will. And then divide by 40,000. And it gives me this answer. 1, 2, 3, 4, 5. Now that's in hours, okay? I need to divide it by, well, I know that there are 24 hours because we want to know how many years. So we know there are 24 hours in a day, and there are 365 days in a year. So to find out how many hours in a year, we're going to do 24 times 365, which gives us 8,760 hours in 1 year. So our final answer, to turn this into years, we're going to do this number here, and we're going to so 998,030,000. We're going to divide it by 8,760. And if we do that, so bear with me for a moment, I'm just going to do that on my calculator, and you should also do it on yours to check. Divided by 8,760. It is roughly going to be 114,000 years. So it's roughly that to 3 significant figures. So he is correct. Okay, and just showing your working is enough to show that he is correct. So let me just quickly tell you where you get the marks for. You got 1 mark for finding out how much time it took. So this calculation here, this calculation here. Then you got the second mark for finding out how many hours in 1 year, and then the last mark for doing the final calculation. Okay, question 16. Let's fill in this table then. Okay, so nearest 10. I think at this point we've done a lot of rounding, so I'm actually just going to quickly give you the answers. And I think most of you got this right, apart from some of you who need to practice your rounding. So this one to the nearest 10 should be 26,460. To the nearest 100, you should have 26,500. To the nearest 1,000, you should have 26,000. To the nearest 10,000, you should have 30,000. So that's nice and straightforward. Right, nearest tens, you should have 3,986,500. Then to nearest 100, you should have 3,986,500 again. To the nearest 1,000, you should have 3,987,000. To the nearest 10,000, you should have 3,990,000. Okay, next one, to the nearest 10, 6,390. To the nearest 100, 6,400. To the nearest 1,000, 6,000. To the nearest 10,000, it should be 10,000. Okay, because this is gonna make it round up. There are 0 10,000s. It's gonna round it up to 1 10,000. The next number. Okay, so we have to be careful with this next one on the last one, but I'll quickly show you. So we've got 960 to the nearest 10. To the nearest hundreds, this rounds up, so it pushes up to 1,000. To the nearest 1,000, it's also 1,000. And then to the nearest 10,000, you have to be careful. If you look at the place value, so 10,000, you've got 0 of them. Thousands, you've got 0. Hundreds, you've got 9. Tens, you've got 5. And units or ones, you've got 9. So we want the nearest 10,000. We cut it off here. Are we going to leave it as 0, or are we going to round up? To do that, we have to look at the next number, which is also 0. So we're going to leave it as 0. A bit of a trick question, and some of you got it right. But yes, you needed to get at least 3 to get 1 mark, at least 6 to get 2 marks, and then all correct to get all 3 marks. Okay, another rotation. So remember, when we're doing a rotation, you need to put your tracing paper over the shape, including your center of rotation, which in this case is 3 minus 1, so here. Then put your pen or pencil down and rotate it anti-clockwise. So we're going this way now, and it's a quarter turn. So we do a quarter turn anti-clockwise, and your shape ends up being here. Oops. Like so. Okay. All right, last question then, which I know some of you didn't quite like. You have a cardboard, and it's measuring 23.5 centimetres by 30.8 by 17.25. 1 centimetre cubed is equal to 1 millilitres. What is the volume of the box in litres? Correct to 3 significant figures. So there's lots of things there. First of all, you need to find the volume. So you need to do 23.5 times 30.8 times by 17.25. This will give you the volume in centimetres cubed. So remember, to find the volume of a cuboid, we multiply all the lengths together. And so again, you can get your calculator out and do that. And I have got 12,485.55, and that is centimetres cubed. Now it tells me that 1 centimetres cubed is equal to 1 milliliter. So actually I might round it to 3 significant figures now. So to 3 significant figures, 1, 2, 3, cut it off here. And I'm going to, the next number tells me to round up. So it's 12,500 milliliters. And then to turn it into litres, I know that there are 1,000 milliliters in 1 litre. So to turn it into litres, I'm going to divide by 1,000, which gives me 12.5 litres. And that's it.